Lesson 6.1 is going to be on nth roots and rational exponents. Here are just a few examples of different roots and exponents. This first one, if your symbol just looks like what it's always looked like, that radical sign, this is the square root of 64 and it equals 8 because 8 times 8 will give you 64. We're going to start to look at other roots as well. If it's a different root that you're taking other than a square root, you're going to see that number show up right there. This means the cube root of 8 is equal to 2 because 2 times 2 times 2 will give you 8. It takes 3 of them. I'm going to skip down here. We also have this expression where, because the 5 is there, the fifth root of 32 equals 2 because it takes 5 of those 2's. 2 times 2 times 2, 5 of those to get to 32. And that's kind of what this started out with. 2 to the 5th power is 32, so that means the 5th root of 32 gets you back to that 2. We have two different notations that we're going to concentrate on in Chapter 6. Radical notation is when you are using the radical symbol and you're taking some root. Rational exponent notation, I'll show you how these all convert into the other notation. This first one, just the square root of x, what they're not going to bother to write in there for you is this squared right there. The square root means that you're taking the second root. To write this in rational exponent notation, it's going to be x to the 1/2 power. This 2 right here in the denominator indicates that you're taking the second root of x. So rational exponent, rational is a fraction, so your exponents now are going to be fractions. The next example, the cube root of x in rational exponent notation is x raised to the 1/3 power. The fourth root of x is x to the 1/4 power. So do you guys see what's going on here? Whatever root you're taking, that root is going to end up right there in your denominator. And so if your root is n, the nth root of x, it'll be 1 over n. So it doesn't matter what root, we know that that's where it will show up in the other notation. So these are equal. The square root of x is equal to x to the 1/2 power. Two different ways of writing the same thing. The cube root of x is the same thing as x to the 1/3 power, and so on and so forth. You're going to have some questions like this in your homework. It says find the indicated real nth root or roots of a. So what they're saying is a is, like your base. That's going to go inside here. And what root are you taking of a? That n is going to go in there. So the second root of 64 is the same thing as the square root, which is 8. This next one, our a is -16. So we have a -16, and we're taking the fourth root of it. Well, one thing that we're going to come across is you cannot take an even root of an odd number. So this one actually cannot be done. Because what we're saying is that means we'd have 4 numbers, well that got sloppy, but 4 numbers that we're multiplying together that will give us -16. Well, a number that multiplies 4 times would be 2. So 2 times 2 times 2 times 2. That gives you a +16. We also could look at what if they're all negative. Well, if you multiply a negative number 4 times, that also equals a +16. So there isn't a number that we could multiply 4 times to get that -16, which is why the fourth root of -16 does not exist. We could work through this and bring in I, like we did back in Chapter 4, but it says that we want real roots, so we're not going to use imaginary roots. This next one has a little bit of a typo. Well, that's weird. Okay, I think this is what a should be. So we're saying that the 343 is under our radical, and we want the third root of 343. And so what number do you multiply by itself 3 times to get 343? And that is 7. You guys have all received an exponent table. Your exponent table you'll be allowed to have out for quizzes and tests, and that's the chart that has all of your exponents as well as all of the roots on there. You can work forward or backwards through your table and get these answers pretty quickly. So as we start to first learn about the different notations, they just ask us to rewrite between the two notations. So this first one, the fifth root of 14, that's the same thing as saying 14 raised to the 1/5 power. Whatever the root is has to end up in the bottom of a fraction right there in your exponent. The next one, 92 raised to the 1/8 power. And this next one, we have an extra, we have the root, but then we have this exponent right here. And so that 11 is going to be the base in our rational exponent notation. And when you have these two numbers to put together, just remember the 6 is the root. That has to go in the bottom here. Your power, we're raising it to the third power, that's going to go up on top. And then our exponent is 3/6. We can go ahead and reduce that to a 1/2 power. And that will end up as 11 to the 1/2 power. So in here we have our rational exponent notation. They just want us to rewrite into radical notation. So radical notation, the base of your exponent, what's what goes underneath your radical symbol. And then to figure out where the other numbers go, just remember that this denominator is your root. So that's the 4. And then we could say we're raising it to the first power because of the 1 right here. But raising something to the first power doesn't change it, so you wouldn't necessarily have to put that there. 8 to the 1/5 power is, the 8 goes in here. And then we're taking the 5th root, so that's where the 5 goes, and again that power of 1 doesn't matter. Next example, 26 goes in here. Your root is 4, and the power of 3, we'll throw parentheses around this and raise it to the third power. So you're going to have to do problems where you evaluate expressions without a calculator. And I think if you work with these problems in 2 steps, then they're not that hard to do at all. It's just a matter of getting used to it. I did go ahead and add something to this problem. I decided to raise it to the third power just to give you a better example in your notes. So following your order of operations, let's just start inside the parentheses. Don't worry about that third power yet, but do we know what the 5th root of 32 is? And if you use your exponent table, because it's the 5th root, go to the x to the 5th column. And if you look at that, you'll see a 0, a 1, and then you do see a 32 next. And if you look to the left, there's a 2 all the way on the left, because they're saying that 2 to the 5th power equals 32. Well, we can work backwards with this. We can say that the 5th root of 32 is 2. So this 5th root of 32 inside here becomes 2. And now we can raise that to the third power. 2 to the third power is 8. And our final answer on that will be 8. Sometimes we are asked to evaluate expressions with a calculator. You may or may not have a button that allows you to do other roots very easily on your calculator. Some of them I know have a cube root button. Some of them will let you put in any root. But for sure, what you can do with these is rewrite them into radical or rational exponent notation. We can say this is the same thing as 24 to the 1/3 power. And you can type exponents into your calculator. You do 24 and then use that little, I think of it as a carrot top, I don't know why, parentheses 1 divided by 3 parentheses, and that will get you the same answer as the cube root of 24. So if you want to take a look at your calculator and try that, you should get a 2.88, I believe, if I'm remembering the number right. So that'll just let you know, all right, how you doing with your calculator. So give that a try. All right, our last idea in section 6.1 takes us back to solving equations. I think a lot of this will be very familiar to you guys, but just you know how to solve using square roots, where you square root both sides, and you know if you square root both sides, we throw in the plus or minus because you get 2 answers. We haven't had to talk too much about that yet, but now you may be taking other roots besides square roots. So when solving an equation with x raised to any even power, there will always be two answers. So basically, if you're taking an even root when solving an equation, you will have to bring in plus or minus. So if you have an even root, you bring in plus or minus to your equation. I'm going to skip this problem just because we've done that. Let me go to one that looks a little bit newer for you guys. Alright, this is a good example. If we are going to solve this equation, we know at some point we're going to have to undo this exponent right here. So let's try to get that alone. We'll start by subtracting 2 from both sides. So we have 3x to the 4th equals 3. Then we'll have to divide by that 3, and it leaves us with x to the 4th equals 1. Now if that was x squared equals 1, we would square root both sides. Because it's x to the 4th, whatever this power is, to undo that, we're going to take that same root. So to undo an x to the 4th, I'm going to take a 4th root, because the 4th root cancels out the 4th power. We do need to take the other side of the 4th root also. So the 4th root cancels the 4th power, so we're left with x. But here's the thing we have to remember. We just took a 4th root, which is even. So that means I know I have to bring in plus or minus. So it's plus or minus. And then what's the 4th root of 1? Well, 1 times 1 times 1 times 1 is 1. So we get x equals plus or minus 1. So I'll have that be the last example in the intro video. Make sure that you do watch the other concept videos though, because this is just a quick peek at what the chapter's about, but those will be the main ideas going into more depth. On this one where you're solving equations, I mean, you can kind of look ahead and know that whatever power you're raising something to, that is the root you end up taking. So if it was to the 5th power, we would take the 5th root in solving. If it was to the 3rd power, we would take the 3rd root, and so on and so forth.